One good day, geometry. We have made it to our final objective of the unit, and it's a PO because look at all the objectives that are going to be helpful information to do PO15. Basically, because now we take all those individual rules and we put them all together. You'll be multiplying by the same base with negative exponents. Well, you got a zero power in parentheses with dividing by the same base on the outside. Sounds fun, okay? So this is what I would recommend you put on a help sheet. You can put these 5 rules on it, and you can summarize them as simply as just, CEB, coefficient, exponent, base. What happens to each one when we are multiplying by the same base, divided by the same base, zero power, etc., etc. Okay? So thinking back, multiplying by the same base. An example would be something like 3x to the 4th times 7x squared. What happens to those coefficients? Blake, they get multiplied, right? Okay, you would multiply 3 times 7 to get 21. What happens to the exponents? Will, you add them. Okay, and the bases, those x's, they stay the same. So for multiplying by the same base, there's an example of it. Those coefficients get multiplied, exponents added, base stays the same. This would equal 21x to the 6th. Right, 21x to the 6th. That's how you would simplify it. Dividing by the same base. An example might be 14n to the 5th over 10n to the 8th. Okay? What happens to our coefficients? Yes, James. Not the coefficients. The exponents get subtracted. Our coefficients, Peter? No, they don't stay the same. The base stays the same. The coefficients, Joey, get simplified. Okay? It is a fraction, right? So those coefficients, that 14 tenths, we would simplify that to be 7/5. The coefficient gets simplified. And then as far as our exponents, how many more n's do we have? Or how many n's will we have left? And where are they going to be? William?
3 more in the denominator.
3 in the denominator. Why? Because we have 3 more there to start with. Okay? So this expression simplified would be 7 over 5n cubed. If our 8 n's were in the numerator and our 5 n's were in the denominator, then the 3 n's would be up top. Right? It's where we've got more to start with. That's where they will end up. The 0 exponent. We can kind of fill in the exponent because by definition it's going to be a 0. Okay? What happens to the coefficient and the base for a 0 exponent? An example of this might be 10n to the 0 power. Blake? Nothing happens to the coefficient. This is the one where the coefficient stays the same. Because what's the rule for any base to the 0 power? If you forget on test stage, you can look back at the purple square in my hidden math poster there. Well, it equals 1. Okay? The base becomes a 1. So this ends up being essentially 10 times 1, which equals 10. Okay? This is the only one where the base changes. Only one where the base changes, it becomes a 1. Negative exponents. The example of this one might be 2n to the negative 8th over 3xy to the negative 6th. Oofta. What would happen to our coefficients there, the 2 and the 3? If we could simplify them, then we would, right? But 2/3 we can't. So stay the same. Nothing happens. Okay? Or maybe for this one we should stay put, right? Because that negative power rule is all about moving things. And in this case, the coefficients stay put. What about the exponents and the bases? Peter.
The negative exponent move to the other side.
Okay. The exponent moves to other part of the fraction, and it also becomes positive. Right? By moving it, we're allowed to turn it positive. And how about the bases, the n, the x, and the y? What happens then? Or to them? Blake. Right. Move with the exponent. But they stay the same. And the reason why I want to put that in there is because oftentimes if you make a mistake, you're going to make a base negative. You don't. The base doesn't change. The power becomes positive. The base stays the same. So for this one to be simplified, our 2 being a coefficient would stay put. Our y to the negative 6th would move up to the top, becoming y to the positive 6th. Our 3 would stay put. Our x would stay put because that's got a positive power, so it does not need it to be moved. And then n to the positive 8th, once it moves down, that would be our final answer. Okay. And then the one we just learned, distributing an exponent into parentheses. I've got VC because this stands for, no, it doesn't. I think it stands for variable coefficient. That wouldn't make any sense. Variable coefficient. Maybe it's supposed to be, well, we'll just get rid of the V. Yeah, very cool. I don't know. What happens to the coefficient when you distribute that exponent into parentheses? An example being what we just covered. If we have like 4 x to the 4th cubed, or to the 7th, so that looks more like a 7 than a 3. What would happen to that coefficient 4? Yeah. Takes on the power. Okay? Or gets the power. You can change it if you want to. You can multiply out 4 to the 7th, but you wouldn't have to. You can leave it as 4 to the 7th. The exponents, if something already has a power, Joey, get multiplied. And the variable base, that's where I was going, I think. I don't know if this was the VC, but the coefficient could change if you wanted it to, but the variable base, this x, when we write this out to be 4 to the 7th, x to the 28th, again, that variable base stays the same. Okay? That variable base stays the same. And so PO15 here is just a combination of all these rules that we've done so far. The good news is that there's no real order of operations per se as far as which order you do the rules in. You can do them in whatever order that you want to. As long as you do everything you need to, order doesn't matter. Okay? So, how many are on the front page? 8? Any of those 8 you want to look at in the 6 minutes that we've got left here? Caleb? The last one. Yeah. I will advise you, if you can simplify within parentheses first, you should do it. So what can I instantly just get rid of from this last one? Caleb? The z to the 0 power. It just equals 1 anyway. Okay? Even if I distribute in the 5, 0 times 5 is still 0. So that power is not going to change. It's just get it out of there. Okay? Now, recognizing that what I'm doing inside my parentheses is essentially multiplying fractions, right? I can rewrite this with my numerators and denominators combined. because they're both just fractions. N to the 9th times x to the negative 3rd is just n to the 9th x to the negative 3rd. My denominator is x to the 7th times n cubed is just x to the 7th times n cubed. Okay? Now I could go ahead and distribute here if I wanted to, right? But I also see that I've got some like bases here. So at the end of the day, how many n's do I have and where are they? I've got 9 in my numerator, 3 in my denominator. Drew? 6 n's in the numerator. My x's, I've got negative 3 in the numerator, 7 in the denominator. William?
4 in the denominator.
If I had positive 3 in the numerator, 4 in the denominator would be correct. But since it's negative 3,
Negative 4?
not negative 4. Sydney? 10, right? And we can think about that two different ways. We can either take negative 3 minus 7, which negative 3 minus 7 is negative 10, which we then move down to make it positive 10. Or we can move our negative 3 down first, turning into positive 3, and combine that with my positive 7 I already have, that gives me positive 10. So either way you think about it, you end up with x to the positive 10th in the denominator. Okay? Now I can distribute, which gives me 30 x's in my numerator, 30 n's in my numerator, or n to the 30th, and x to the 50th in my denominator. Woo! Okay? So just to recap this. First, I eliminated my z to the 0 because it's just 1 anyway. Then, because within those parentheses, I'm just multiplying fractions, this is what they are, I multiply straight across and combine my n to the 9th and x to the negative 3rd just together. Same thing with my x to the 7th and my n cubed here, right? Just combine the fractions because you multiply straight across and there they are. Then I simplified my bases of n, right? To get n to the 6th in my numerator, 9 minus 3 is 6. And then I simplified my bases of x, one of the two ways that we talked about, and I ultimately end up with positive 10, x to the positive 10th in my denominator. Then distribute 5 times 6, 5 times 10. There's my final answer. Okay? Any 3 minutes left now. Any others you want to do? Drew? Why not? Again, multiplying fractions here. And whenever I multiply fractions with powers, I just like to put them all together. To me, it just makes it easier to see what I have. So I've got how many x's total in my numerator here? X to the 12th times x to the 13th. Total of 25. Right. So x to the 25th, n to the 7th. In my denominator, I only have one base of x, so that's x to the 5th. And how many total n's do I have there? N to the what? 9th. Okay. Now combining it, I've got only one base of x, one base of n in each part of my fraction. Now I can look at, do I have negative powers to move? Do I have to distribute? Can I simplify my bases? X to the 25th over x to the 5th, what does that simplify to be? How many x's and where are they? Peter? X to the 20th. And n to the 7th over n to the 9th. How many n's and where are they? Joel? X to the 20th over n squared. Okay. Tomorrow I am out. Friday is a retake day. So PO15 parts 1 and 2 are due for Monday. It's Wednesday. It's due Monday. Okay. PO15 parts 1 and 2. The remaining 6. The second page is a grand review of everything. Every rule. You see we kind of break it down a little bit. focus on every rule specifically. Okay? Mackie.
So we get the con assigned tomorrow and we still have access to last.
Yes, so tomorrow you'll have access to 8 assignments, 4 that are due tomorrow night, 4 that are due the following Thursday. Anything else? Questions, comments, concerns, complaints, compliments, congratulations, or criticisms? All right, folks, I'll see you Friday. That's how you math.